All right, students, let's talk about 5.2. So this is 5.2 here. Okay, let me use a red 5.2. And 5.2 is really just building on top of 5.1. We've got a couple more rules or laws of exponents to go through. And the first one is the zero exponent. And you can see that right here, the zero exponent. Yep. And what it's saying here is when you have a base to the exponent 0, it's equal to 1. Anything to the exponent, any base to the exponent 0 is equal to 1. Okay? There is no exception to that rule. If you see a base to the exponent 0, it is equal to 1. Okay, this even works, just as a side trivia point, to 0 to the exponent 0, because there is a fair argument out there that 0 to the exponent 0 is 1. Okay, but then you could also say 0 to any exponent, 0 multiplied by itself this many times, however many times, 0 times 0, 0 times 0, 0, 0, 0, however many times you want to multiply 0 by itself, you're still going to end up with 0. So there are actually two arguments out there, and the best thing I can say is you can watch some YouTube videos on it if you're actually curious. But 0 to the exponent 0 is arguably either 0 or 1, and because you can't actually multiply it, you can't actually solve it, the best thing we can do is come up with a good guess, and it's either 0 or 1, or a better term to describe it is indeterminate. Very interesting point. But nevertheless, let's get to what we need to talk about. Okay? Zero exponent. Here we go. Let's look at some examples. Right up in the top here, I've got -3 to the exponent 0. So you guys all remember that if -3 is the base because the 0 is sitting on this, then simply this is the whole -3 to the exponent 0, which is 1. That was easy. Okay. Anything I need to say about it? No, not really. Let's move on. Look at this one. This is -3 to the exponent 0. Well, what's your base? See, this really is -3 to the exponent 0. Some of you guys who I taught before would remember this little problematic situation. But remember, this is actually the negative, right? Because that's the multiplying. We've got to handle the exponent first. 3 to the exponent 0 is 1. And look at that. -3 in brackets to the exponent 0 is 1. But -3, no brackets, to the exponent 0 is actually negative, and then 3 to the exponent 0, which is -1. Understand the difference. Okay, that's all I really need to say about anytime you have a zero exponent. Just understand that, apply that to the rules. It should be straightforward. Okay, let's talk about a negative exponent here. What if you have a negative exponent? The negative exponent rule means a base to a negative exponent is the same as the reciprocal to the positive exponent. In fact, it's probably better for me to write it like this. A to the exponent -x is equal to the reciprocal, which is 1 over a. That's what we call the upside down version of it, okay? To the exponent x. Okay? And a reciprocal to any number, if they were multiplied together, like for instance, the number 5, the reciprocal would be 1 over 5. If they were multiplied together, they would equal, okay? That's what a reciprocal is. All right, so let's get at it. Over here, our first one we want to talk about is right here. This -4 to the exponent -2. Okay, so let's handle this in two stages. We're going to deal with the negative first, and then we're going to deal with the 2 in that order. So let's handle the negative first, and let's see what happens here. The negative causes this -4 to flip upside down and become, you could write the negative here, doesn't matter, 1 over 4. That's what the negative did. And all I have left is the 2. Okay, because that highlighted negative caused the reciprocal, and the reciprocal happened, and that's what I have. Okay, the next step is to handle the 2. So if you remember, the 2 needs to go into both of these terms, and what we end up with is negative 1 squared. You can imagine that the negative is either on the 1 or on the 4, okay? But it can't be on both. So you can imagine that this is negative 1 all squared, and this is 4 all squared because the 2 goes to both. And I end up getting what I have here, which is 1, just kind of disappeared, over 4 squared, which is 16. And done. Okay. All right. Let's move on to another one. Let's try this negative 4 to the exponent negative 2. Here we go. Handle it right here. Negative 4 to the exponent negative 2. Now, if you remember what we talked about, this negative 4 is not in brackets, right? And because it's not in brackets, it really is a negative like this. And then it's really 4 to the exponent negative 2. This is a better understanding of what this is, but it's kind of coded, so you got to decipher that. Let's handle it in 2 steps. Let's deal with the negative, and then we're going to deal with the 2, okay? So we'll leave this negative outside. The negative here on the exponent causes a flip, the reciprocal. So 4 becomes 1 over 4, right? Because right now this is actually 4 over 1. So it becomes 1 over 4. And then I still have the 2 now. Let's handle the 2 by sending it into both of these. So this would be 1 squared and this would be 4 squared. If you don't mind, I'm going to do that in one shot. This gives me 1 over 16. And we are going to send in the negative and call it negative 1 over 16, which should be fine. Good. Tracking right along. Let's do with another negative exponent situation. What about this? 8 to the exponent negative 3 divided by 8 to the exponent negative 5. What's going on? Okay, so let's think about it. We could try to apply the negative and flip it, and try to apply this negative and flip it. That's actually possible. Maybe I'll do it underneath if you want to see what happens next. However, you need to recognize that we are dividing right here, right? Look here, we've got the same base. Right, the same base, which is 8, and the negative 3 and the negative 5. Remember, the dividing rule or the quotient rule says if you have the same base and you've got exponents on them and they're being divided, these bases are being divided, then you can just subtract the exponents. So I'm going to try to take this line first because this is what I advise you to do, is if you have the same base, recognize it, and let's go negative 3, subtract the negative 5, which is 8, and then negative 3 plus 5, which is 8 squared, which is 64. Okay, now let's say you went off the deep end. You're like, I want to do something a little crazy here. I'm going to try to figure this out. Okay, for those of you guys who want to see what that looks like, that's where some kid is going to say, well, this is 8 to the exponent negative 3. Well, what is that? That's 1 over 8, right, to the exponent 3, all divided by 1 over 8 to the exponent 5. Some kid's going to do this. But they're going to flip these. Are they wrong? Actually, no. Let's check out what happens next. What actually happens here is I'm going to call it 1 over 8 to the exponent 3, which is really it's 1 cubed over 8 cubed. Okay? Or I'm going to write 1 over 8 to the exponent 3. I mean, there's a 3 on that one, but honestly, that just becomes 1, right? Divided by 1 over 8 to the exponent 5. So far, so good? And look at all these dividing signs. There's a weird little hamburger that we created. I'm going to change that dividing to the operator dividing. I'm going to write it like this. 1 over 8, 3, divided by 1 over 8, 5. 8 to the power of 5. Okay, so far so good? Tracking? Remember, when you're dividing fractions, what you're supposed to do is you're going to take the dividing and turn it to multiplying. Then you got to take the second fraction and flip it upside down. This gives us this. 1 over 8, 3 times 8 over 5 over 1. And what's this give you? Well, it gives you 8 over 5 over 8 over 3. And you can subtract the exponents. 5, subtract 3. This gives me 8 to the exponent 2, which is 64. And do you see it? You get the same thing either way, right? However way you want to do it. But I would definitely recommend doing it this way first, because that's a more logical way of doing it. Okay, but if you wanted to test your practice of your fraction skills, go ahead. Let's talk about the last one here. Let's bring it home. Okay, 3/8 to the exponent 0, all divided by 2b to the exponent 3, all to the exponent of 2. So let's look inside the bracket, because we've got to do bedmass in that order. And 3a to the exponent 0, 2b cubed, I can rewrite that. And I'm going to write it like this, actually. 3 2b cubed. Why? Because a to the exponent 0 is 1, and that's 3 times 1, which is 3, right? I still have the 2 here. Okay, now let's apply that 2. Let's be very careful. That 2 needs to be applied to the exponent on the 3. 2 needs to be applied to the exponent on the 2, and applied here. What really happens here is there's a 1 on that 3. Okay, there's a 1 on that 2, and there's a 3 on that b there. So this becomes 3 to the exponent 1 times 2, which is 2, over 2 to the exponent 1 times 2, which is 2, and b to the exponent 3 times 2, which is 6, giving me 9 over 4b6. Okay, and that's how you handle dealing with a zero exponent and a negative exponent. Let's get some practice at that stuff. If you haven't done all that IXL stuff, here it is again back at you. Try to finish it all, because it does actually capture zero and negative exponents in there as well, except for that I.4. Don't do it. And then the workbook, page 77, 1 to 5 and 7 to 8. This is where these zero and negative exponents happen. Try to do that as well. That'll give you some pen and paper practice, stuff like what I just did here, and that's a lot of the heart of where this work is coming from. Okay, so have at it, get some practice. Those of you guys who know this stuff, we're going to fly right through it. Just please make sure you check the answers, and anything you don't get, drop me a line. Just send me an email, and you'll see that I normally get back to you super quick, and I'm pretty helpful at that, right? So keep up at it, and take good care. Bye.